Greetings, children. Here's section 10.3. We're talking about the 30, 60, 90 triangle theorem today. Just to give it to you in a nutshell, if I drew a triangle over here, it's got to be a right triangle, always. If you recall, we would say, okay, this is side A, this is side B, this is side C, right? Now, C is the hypotenuse, and A and B are the legs. The rule of thumb with this theorem is that whichever the shortest leg is, let's say he's A, you call him X. The hypotenuse is always going to be 2 times that size. So he's going to be 2 times X. So whatever A is, C is going to be twice as much. Now how long is B? Well, this one's just a little trickier. He is radical 3 of A. Basically, if you think of radical 3, it's making a number smaller, right? So he's shorter than A by radical 3, so you just say X radical 3, okay? So whatever this is kind of your base number here that you'd be going off of, or this one probably, okay? But that's what this theorem's talking about in general, okay? The shorter leg, we'll call him A in this one, is always X. The other leg would be X radical 3. The hypotenuse is always 2x. So, scrolling back over to example 1, we want to find the length of side A, okay? So as we look at example A, okay, here's your legs, okay? So this is A. That means that this side here would have to be B, which obviously this has to be C because he's directly across from the hypotenuse. Now, since this guy is 20, this guy's 10, it means he's half of this, right? So if you go back to what we talked about just a minute ago, alright, so like here, this guy is 20 and this guy was 10, he's half of that, right? So that means this is actually the shorter side. This is going to be the radical 3 side over here. So all you got to do is this side is basically now 10 radical 3. So now you just got to multiply 10 radical 3. So this gives us 17.3. Okay? So that is the length of this other side. Okay? Example 2, want to find the hypotenuse length. Okay, so you can see that they give you 23 here. Alright? And then one other way is you think, okay, well, is he going to be A or B? Well, here's the thing. Look at the angles. The smallest side is always going to be opposite the smallest angle, right? So there's the smallest angle is 30. So that means 23 is the smallest side. So to figure out what C is, he's 2 times. This would be X, right, or the A. Okay, this is going to be B. And so we're just going to take 23 times 2, which is going to be, whoops, not 60, whoops. How about 46? So this is, C will be 46, okay? If you wanted to figure out B, then you would just take 23 times radical 3. It didn't ask us to do that, but that's how you would figure out the length of this side here. Okay, so just go off of the angles too to help you. Just like in this last one, 60, we were opposite 60, so that means he's got to be the second longest side. Here's 30, that's why we knew this is the shortest side right here. Find a longer length. Okay, so again, take a look. You're opposite. Here's the smallest angle. That means this is the smallest side. So this would be like the X. The hypotenuse would be 2x. This would be x radical 3, going off of our theorem. Okay. So we just want to figure out the longer side, which is this one. So all we got to do is take, instead of x, we're going to say, okay, it's 12 times radical 3, which after you round it is going to be 20. Whoops, that's a pretty crappy zero. 20.8. And again, if you want to figure out the hypotenuse, he's just 2 times whatever x is, so that'd be 24. Okay? Once you get into the groove of these. It's not too difficult, really. All right. We want to find the shorter length here. So again, here's the smallest angle. So that means this is the shortest side. Okay. Now they give you the longer leg here, right? So again, let's just keep labeling. Okay, this was x. This one's x radical 3. This is 2 times x. So if he is 19, we got to do a little bit of algebra here. So we're going to say, okay, x radical 3 equals 19, because that's how you get it. All right, you take this times radical 3. That's how we get the 19. So to solve for x, we got to divide by radical 3. Okay, so x is going to equal, you should get 11. It should be 10.969, which would round up to 11. Okay, so that would be the length of the shorter side. All right, just had to do a little bit of algebra there. And we could say, like in a book, they'll say x is about kind of a squiggly equal sign there because we rounded it. Okay, last example. Want to find the lengths. Okay, now we need to find both legs. It's no big deal. We've done them in the other examples here. But again, let's label our parts. Here's the shortest, the smallest angle, so this is the shortest side, so he's x. There's the middle, the 60, so he's going to be the x radical 3, and that makes this the hypotenuse because he's opposite the 90. He's going to be 2x. So the easy one to figure out is, since he's 10, he's half of that, right? Because he's 2 times it. What's half of 10? Yeah, you should be thinking 5. So x would be equal 5, that side. And then this side over here is going to be now 5 times radical 3. So just put that in your calculator. 5 times radical 3. I got to work it out. I got 8.7. Okay. So this side here is 8.7. Okay. So kind of in summary, looking at all of this, whoa, where are you going here? Okay. I think the biggest thing to remember, guys, is remember that which sides are these? The shortest side is always going to be opposite the 30. The 60-degree angle is going to be opposite the x radical 3, like this. And then the hypotenuse is always opposite the 90. Okay? But as you saw that I was doing in my examples, I kept labeling the triangles with the sides the whole time. Okay? And that kind of helps give you a baseline. Okay, what side did they give me, and where do I need to go from here? All right. Really, probably the only tough one would have been like example 4 here, where you had to set up an equation because we were given the longer of the 2 legs. Okay. So hopefully you got an idea of the 30, 60, 90 triangle theorem. Do have a great rest of the day.